So we have related rates. This is 2.6. An important use of the chain rule is to find the rate of change of two or more related variables as they change respect to time. So an example, we have a cone-shaped tank that has water, and it's losing water over time. So we have the volume, since it is losing water, you can see in the pictures, my volume is decreasing as time moves on, but also my my radius of the circle at the top of the cone is also reducing, correct? Yep. So the equation V equals pi over 3 r squared is the volume of a cone. Okay? So in that, we have two variables that aren't changing in respect to each other. They're changing in respect to time. So what we do is we find related rates by using the implicit differentiation. So we have to take it and we have to differentiate it with respect to time.
We need to write down.
So, well, this is important. You find related rates by using implicit differentiation. In other words, we're finding d dt. What's t stand for?
Time.
Time. So we're differentiating with respect to t, which t is nowhere in that formula, is it? No. So how we're going to do that is we're going to take d dt of v and d dt of pi over 3r squared. Now, this left-hand side, you're going to quit writing that as a step, and you're just going to write dv dt. I mean, your brain will just automatically do it, because that's all you're doing, right? The derivative of the volume with respect to time. That's what that says. So now on the right-hand side, pi over 3 is a constant, correct?
Yes.
Okay, so when I differentiate that with respect to t and r do not match, do they?
No.
Okay, so I'm going to have 2 pi over 3, because you have to take pi over 3 times 2, correct?
Mm-hmm.
R, and then we have dr. That's a weird r. Dr dt. Now, where did dr dt come from? We took the derivative of r with respect to time. Make sense?
Mm-hmm.
Now I think I messed up. Yes, because I didn't write the right formula in there.
Oh.
That formula should be, there should be an h after the r squared. Okay, so let's go back then. If there's an h after the r squared, then we have to do the product rule, yes?
Mm-hmm.
And we can fix this. So the product rule says the derivative of the first, which we already took, times the second, which would be h. Yes? Plus the first. My pen won't work. And the derivative of h would just be 1, correct? So that would be dh dt. I was like, that went quicker. I forgot the h back here. Oh, I forgot that. I'm so sorry.
So is that just the formula?
Well, we just took the derivative. So now we got to probably simplify it a little bit, don't we? Make it a little better. Can we bring this h over here next to the r? Yeah. So you have 2 pi over 3 RH dr dt plus, and this one doesn't simplify anymore. I think in the book they factor out a pi over 3. Could I do that? Mm-hmm. Yeah. My pen won't write down here for some reason. If you want to factor out, I know I'm in the no land territory over there. If you want to factor out a pi over 3, some people like, I'll write it off to the side over the picture. It could be pi over 3 and then 2rh dr dt plus r squared dh dt. I guess that looks a little better, doesn't it?
Yeah.
And we'll have to plug in things, so that might be a little easier to plug it in, right? But other than that, yes, we would be done.
I'm gonna fail.
Okay? Way to be positive.
None of that I understood.
Okay, so we're gonna start from the beginning here with just a basic problem without any scenario, just a basic not an application problem, just a computation. Suppose that x and y are both differentiable functions of t and are related by the equation y equals x squared plus 3. Find dy dt. And I think I typed it wrong again. No. When I think I typed it wrong. Just a second. This is what I get when I'm trying to do two things one time. Oh, find dx dt equals 2 when x is 1. Nope. Okay, so find, let me rewrite all this. I know what I did. I combined two sentences. Sorry. So we have the equation there, yes? And we have find dy dt when x equals 1 given dx dt equals 2 when x is 1. So what you're going to do when you approach every single one of these problems, you're going to write 3 things down before you even start. The first thing you're going to write down is you're going to write the word and you're going to write equation. Okay, what is the equation?
Y equals x squared plus 3.
Okay, so you have y equals x squared plus 3. Okay?
Mm-hmm.
Then on the other side, right next to it, you're going to write given. What they give me.
Dx over dt equals 2.
Okay, so they gave me dx over dt equals 2 when
X is 1.
x is 1. And then you're going to write, I'm going to put a line between this because that's the problem there, right? And then you're going to write find. And the reason why you're going to write find is because if you don't write find, you're going to forget what you're finding halfway between the problem, correct? So what are we finding?
dy dt when x equals 1.
dy dt when x equals 1. Okay, so how did we do this? We did implicit differentiation, yes? Yes? So we need to find dy dt, so we need to take d dt of both sides of the equation, like we've been doing for 2 days, right?
Mm-hmm.
So on the left, we get dy dt because I just took the derivative of y, so it'd just be derivative y over in respect to t.
Mm-hmm.
So what is the derivative of x squared with respect to t?
2x dx over dt.
Dx over dt, yes. The variable you have with the variable with respect. Okay? All good so far?
Mm-hmm.
And the derivative of any constant, no matter what, in terms of it is 0.
0.
So I'm done. I found my derivative. Okay? So I found my derivative, but I need to find dy dt when x is 1. And it tells me dx dt equals what? What's it tell me? 2. So guess what I do with that?
Plug in 2.
I plug it. So I'm going to have dy dt 2 times what's x?
1,
1. And what's dx dt?
2.
2. So dy dt equals what?
4.
4. When x is 1.
What was our 1 and 2?
We're plugging into this equation right here
Yeah, but where do we get the numbers
from your given. Your given says dx dt equals 2 when x is 1.
When you just explained it though, you said 2 and then we got 1 from dy dt.
No, yes, 2x, what's x? 1. And what is dx dt? 2. We got those from your given information. So every problem we're going to write down what? Equation, given, find. Then you're going to find the implicit differentiation. And then we did what? Substituted? Every one. Every problem.
Are we only going to have, like, differentiation by t?
Yes, because we're doing application problems, so everything changes with respect to time. Okay, so we have a pool of water. We have a scenario here. It says a pedal is, and you see, that should be pebble. I need to proofread.
Pedal. It's just a bike pedal.
Mhm.
Sorry, that's really
A pebble is dropped into a calm pond, causing ripples in the form of concentric circles. Okay, concentric circles are circles in with other circles. Okay, there's a picture. The radius r of the outer ripple is increasing at a constant rate of 1 foot per second when the radius is 4 feet. At what rate is the total area of the disturbed water changing? At what rate? So at what rate is the total area of the disturbed water changing? Okay, so we have equation. Okay, so what shape is that? Circle. And what are we looking at?
The area.
Area. So what's an area of a circle?
pi r squared.
Pi r squared. Are you maybe going to have to look up a few equations? Yes? I want given. And I want find. Now, I wrote those on the other side last time, didn't I? So we could differentiate there. Sorry. Doesn't really matter. Okay. So sometimes you find your given before you find your find. So I write with words and I put it where it goes. Make sense? So I read back through my problem and it says the radius r of the outer ripple is increasing at a rate of 1 foot per second. So that's probably a given, right? Not a given?
Yeah.
So radius changing, so that would be dr dt, because that's change, isn't it? Dr dt. And why is it r?
Because it's radius.
And why is it t? Time. Equals 1 foot per second. Okay. When what?
When the radius is 4 feet.
So when r is 4. So what are we supposed to find?
Total area.
So what rate is the total area? So that would be DA, capital A for area,
Yeah.
DT. Okay. So this one doesn't have a when anything happens, does it? So do you see how we picked apart that problem before we started doing anything else? Sometimes I put my find down first because my brain says, "Ooh, that's fine, do it." It doesn't matter which way you do those. So next thing, what am I going to do? I'm going to take the derivative with respect to time, right? So I'm going to take my problem and do dt. So on the left, I'm going to get dA dt. And on the right, remember pi is a constant.
Mm-hmm.
So what is that? 2 pi r dr dt.
And then plug
And then plug in.
in for drdt and 4 for r.
Yep. So we have dA dt, and we just go up across our equation. So I have 2 pi and r is what?
Oh, 4.
4, because it's in our given, right? And dr dt is 1. So dA dt, 8 pi. Oh, we got area, so it's going to have to be feet per second squared, right?
Yeah.
Oh, square feet per second. Sorry. I was like, wait a second, we can't square the seconds.
I mean,
We could, but yeah, you don't. Questions?
Where'd you get 4 from?
Right here it says the
Oh,
constant
when R
rate.
equals 4. Never mind.
So once I've written down my equation, my given, my find, should I be okay? Should I be done basically with my problem? Now, helpful hint, if you find your derivative with respect to time and you have a variable on the right that you don't have a given for, did you do something wrong? Yes. So if you have, let's see, we have an H and an R. Like our first problem had an H and an R, didn't it? So I would have to have information for H, for R, for DH dt, and dr dt all in my givens to find something specific. So if you've gone through, something went wrong, you missed information, you wrote down much information, whatever. Let me know when you guys are ready because I have a list of what we just did if you want to write it down.
maybe I'll just skip and do that.
Okay. So what we just did, guidelines for solving related rate problems. Identify all the given quantities and quantity to be determined. Maybe make a sketch, right? If it would be good to make a sketch, make a sketch. We wrote down, what were those things?
Equation, rate. No.
Yep, equation, given, and find. And if a picture would help you, should you make a picture? Yes. Okay. Write an equation involving the variables whose rates. Now, this number 2, these are the steps out of the book. Okay? 1 and 2 we did together, didn't we? Didn't we write an equation when we were doing that? Yes? Like, write an equation involving the variables whose rates of change rates of change which are given and are to be determined. So when we do this, the equation is right here, yes? And the to be determined is the what? Find? So could you compile step 1 and 2 together, basically?
Yeah.
Yeah. So what I tried to do here is I tried to type. Evidently, I had typos. I want you guys to learn how to paraphrase these lists to make more sense to you. Does that get what I'm trying to get?
Yeah.
Okay, using the chain rule, implicit differentiate both sides of the equation with respect to time. That was what? dt. After completing step 3, substitute in the resulting equation. Into the resulting equation all known values of the variable and their rates of change. Then solve the required rate of change. Did we do all those steps?
Yep.
Yep. We basically did a 3-step process. They have it in 4. Because I don't know why you would make 1 and 2 separate things. That seems like a lot of work to me. Means like you're double working, aren't you? So when I read these problems, maybe I'm going to have to read them twice before I know exactly what I'm finding and what I have. Correct? You are also going to need the equations. They're not going to give you the equations. We had to say, okay, we're doing area of a circle. So what is the area of a circle? What is the volume of a cylinder? So those are the equations we're going to be working with. We're going to be dealing with 3-dimensional objects, obviously, if you have more than one variable. I think our next example has a sphere, a volume of a sphere. So we're going to have to figure out the volume of a sphere. Now, those are things that are not horrible to remember, but we don't use them all the time, do we? I think your problems today are more just basic, like the first one we did. I don't think it's I don't think it's like word problem. I don't think so. It could be, but that's okay. Tomorrow we'll just go through them again.
Okay, I understood the examples that we did, the word problem too. It was just a little harder to pick apart. But
And it's just
I don't get any harder than that.
the whole thing is just the practice picking them apart. I mean, the problems themselves are not that hard. It's just picking apart the application of it.
Yeah.
Is everyone ready? Shelby, you good? Okay. I couldn't tell if you were done or not. And again, that's the hardest part, is picking apart the application problem and making sure you have the right given and the right find. And there's times I'll do these problems and I'll be working them. I'm like, wait a second, I can't be finding that because, I'm looking at the wrong thing. And most of the error comes into rushing through the problem. Done? Okay. Okay, so these are just some examples of readings. These aren't really anything we're going to do. We're just going to look at it. Because like I said, the hardest part is to pick it apart. So it says the velocity of a car after traveling 1 hour is 50 miles per hour. So the mathematical model would be x equals the distance traveled, dx dt equals 50 when t is 1. See that? Mm-hmm. Because we have time is 1, that's your hour, and 50 is your miles per hour. So the change in x with respect to time is 50. I am a big one for units. On the 50, I would put miles per hour. Because if I didn't put miles per hour, I would forget about my units later on. Okay? Water is being pumped into a swimming pool at a rate of 10 cubic meters per hour. So that would be volume, correct? Okay, so volume of the water in the pool. So we need to know the shape of the pool, whether it's a rectangle or whatever. We need to know the shape to have my equation. So I'd have dV dt and 10 cubic feet per hour. A gear is revolving at a rate of 25 revolutions per minute. 1 revolution equals 2 pi r. Yes? 1 circle is 2 pi. 2 pi radian, excuse me. So theta is the angle of revolution. And d of theta over dt is 25 times 2 pi radian per minute. So where'd 25 come from?
Revolutions.
Right, the revolutions per minute. So it's picking apart those. Those are just examples of some things that could occur. Okay, so air is being pumped into a spherical balloon at a rate of 4.5 cubic feet per minute. Find the rate of change of the radius when r is 2 feet. So I'm going to need an equation. Given, what did it give me?
4.5 cubic feet per minute.
Okay, so if it's cubic feet per minute, that's volume, isn't it? Does everyone see that? If it says cubic feet per minute, is that the volume that's changing?
Mm-hmm.
Yes, because it's cubic. So dV dt equals 4.5, and I would probably change that to 9 over 2 because I would rather work with the fraction. 4.5 with 9 over 2, and it's what, cubic feet per second? Find, so that's my find. What am I supposed to find?
Radius.
The radius.
dr.
So dr dt, good job. When what?
When r equals 2.
When r equals 2. So if I'm talking about the volume of a sphere, I need to know the volume of a sphere. So if Mrs. Mick isn't there to tell me something, how do I find it?
Google.
Google. Okay. And the volume of a sphere is V equals 4. I write 4 pi over 3 radius cubed. I think if you looked it up online, it would say 4/3 pi r cubed. I just put the pi with the 4/3 because is pi a constant? Yes. Okay. So do I have my equation?
Yep.
Do I have my given?
Yep.
Do I have my find?
Mm-hmm.
And I've used everything in the problem, right?
Yep.
So what's my next thing to do?
Take the derivative
Okay.
of the equation.
So I'm doing d dt.
Mm-hmm.
So I get dv dt
Mm-hmm.
equals, well, if I take 3 times 4/3, or 4 pi over 3, doesn't that just leave me with 4 pi?
Mm-hmm.
R squared
dr dt.
dr dt. Now, I need to find dr dt. So before I plug anything in, should I be solving for dr dt?
Mm-hmm.
Yes. And this is all multiplication, so how do I move it to the other side? Divide. So I'm going to divide this by 4 pi r squared. So dr dt equals dv dt over 4 pi r squared. So have I solved for dr dt? And that's what we were supposed to solve for.
Mm-hmm.
So now I need to start doing what? Plugging in. So what is dv dt? 9 over 2. and it says 4 pi. Well, those are numbers. And r is
2.
2 squared, right?
Mm-hmm.
So I got to go sideways because I'm running out of room. I need to start making my PowerPoints and then turning them sideways to write on them. Okay, so now I have to multiply. This is 4 times 4, which is 16. Yes? So I get 9 over 2 times 1 over 16 pi. So 9 over 32 pi. And that would be feet per second. Oh, this isn't seconds. It's what?
Minute. Wait.
Yep, it's minutes. My pen won't work. Oh, did you freeze up on me? Come on. Okay, this is feet per minute, guys. Change your given to minutes. My pen has completely froze up on me. Okay, without a calculator, that's what it is. If I approximate it, it's approximately like 0.09 feet per minute. But I'm more worried about our exact answer. And I do not know why it froze up on me. Questions? That's what we're doing. Every problem. Any questions? Okay. That worked, but my pen won't work.